So this is demonstration video 2 for B05, our introduction to coding with R. We're going to look at values, variables, vectors now, and just see how things work in R. As per the Swirl tutorial, we can do simple addition with R, and we can, for example, execute that line using the run command as well, this line on line 54, or we can even type things in here like 11 plus 23 divided by 6 and see what answer we get an answer of 13, just for example. And then we can do division, just putting 20 over 60. We can assign the value of x and y as 2.6 and 1.5. And indeed, if we want to change this to 11.5, we can, for example, assign x using the equal sign as well. So the equal sign also does assignment like that. And we can check what x is down here in the console and see that it's now 11.5. So x was 1.5 before, but now it is 11.5, and it can't revert to the old value unless we change it in the code here. Y is 2.6. We can do multiplications. For example, we can try this one out and see what it'll give us there like that. And do powers as well. So if we wanted y to the power of 26, we do 2 asterisks, one after the other. Square roots, I guess, is another one. The square root of 9 is 3. So the square root is slightly different because we have to use a function, square root, and we give it the argument 9, and it gives us its answer. We can also do things like print x, and note that if we delete the space here, nothing happens at all. If we have many spaces like that, again, nothing happens. It just prints out what x is. So R is quite tolerant of different patterns of coding. So it's kind of up to you the way you want to space things out. It doesn't really matter. We can also use show to say what y is. We can do 5 mod 3 to see what the remainder is, which is 2. We do 4 mod 3, the remainder is 1, and so on. And then what you can do is answer these questions. You can also try these questions where you're trying to put a vector together. So note that to put a vector together, like a vector xx, we can use the C function and add some numbers into there and see what's present by seeing what's there. We can subselect elements of the vector by using the square brackets with the 1. That gives us the first element 12, the second element is 23, the third element is 45. We can subselect multiple elements in different ways. For example, 1:2 selects all the elements between 1 and 2. So if we want to see what 1:2 is, we just type it into the console, and we can see that it gives us the values of 1 and 2. So 1:2 gives us all the values in that range. So 1:12 goes from 1 all the way to 12, like that. 1 to 1000 and 1102, 12, goes all the way up to that. And you can see that R has a maximum output of typically 1,000 values per entry. So I won't go beyond that, but that will be will have been completed by it. So when we're dealing with x, we had xx there. So if we want the xx values that are its elements, we have to subselect inside the square brackets xx, and it basically searches through each element of x and selects the ones that are greater than the criteria that we have, like the ones that are greater than 24. So it just gives us 45 only. If we said less than 24 or equal to, we'd get the first 2 elements. If we get the ones that are even, we can use the modulus function. So it's nicer to put that in the round brackets for visualization, or for a reading at least, for the modulus function. And then we say, is that equal to 0? And that will give us the even elements. And then if we do 1, that will give us the odd elements. So those are some of the key functions that will help you address those questions. The other ones are the mean function. So we can do the mean of numbers 2 to 23, for example, and the standard deviation SD. We can that will get the mean of those numbers as well. Sorry, the standard deviation of those numbers as well. You see here on line 114, we can make a vector of strings and numbers. That's not recommended. You're better off making a vector of containing strings only. So you might call our vector strings and assign a value of being red and white and orange. And in the same way, we can select from strings element 1 to get red, and element 2 to get white, and element 3 to get orange. If we want to select elements 1 and 3, we can use the C command, and that will give us 1 and 3 together. So we get red and orange. If we want element 2 only, we can do that as well. So we get white. So strings, a vector can be manipulated in the same way. The one thing we can't do is multiply a character vector by a numeric one. It will give us an error. And as per the lecture guidance, you'll see this function, the lab guidance, you'll see the function type of. So we can see type of and see what XX actually is. It's a double, so basically it's a number. We look at strings. That's different. It's a character. We can manipulate these if we want to. That's not advisable in this case, but if we said as.character XX element 1, it would give us 12 as a character. So XX element 1 is 12. And you can see the line above, this is viewing it as a character, which is different. If we go further with this, we can see the type of XX element 1 is, as you can guess, a number. But if we do that with an as character function around there, we'll find that it's actually different. It's now a character. So you can actually convert between numbers and strings. For numeric data, that is maybe misread by R. Another feature examined here is this issue that if we have a vector with 3 numbers and another vector with 4 numbers, 5, 6, 7, 8 in Y, if we do XX by YY, this will create an error because the length of X is 3 and the length of Y is 4. So now they're not compatible. What we want is a vector with 3 elements, and then we can do vector style manipulations with each other. So the length of YYY is 3 as well. So if we multiply XXX by YYY, that means we multiply the first element 12 by 9, then 23 by 10, and 45 by 11 for each of the 3 corresponding elements in the resulting output. Oh, wrong one. So you can see there we get 108, 230, and 495. So let's move on further. Yeah, we can do divisions. And yeah, the final part is that if we can create a new vector Z by combining together the elements of XX and YYY and YY if we want to, like that. So now Z has all those elements in there. So it's a length of, it has 10 elements. We can check the structure of Z as well in the same way. And it'll show that it's a numeric data with 10 elements. The structure of strings is that it is a character with 3 elements. Other convenient functions, we mentioned the colon already, is seek, that creates a sequence of numbers. So a start, a finish, and an interval. So 2 to 44 with an interval of 2 gives us this series of even numbers. If we look at rep, repeats numbers many times. So we can repeat the function, the number 1, maybe 999 times if we want. And or we'll just print that to screen. Or we can just do it once if we want. We can also give that vector like this as well, and see how many times it will be repeated, like 11 times. So I'll print out each of the elements sequentially. The final part is up here. When we're subselecting from elements of, let's say, YYY, which is, or YY, which is 3 elements, we can subselect from YY using YY inside square brackets, but we can have multiple criteria. So we can have values greater than 5 and such that YY modulus 2 is equal to 0. So the even elements that are greater than 5. So that gives us 6 and 8. Or we can say the odd elements that are greater than 5, that will give us 7. Indeed, we could change that to say they're greater than 5, or using the vertical line to say either can evaluate as 2. So YY is greater than 5, or Y mod 2 is equal to 0. It's either greater than 5 or even, in which case we got 6, 7, and 8. If we change that to odd, we'll find 5 is included now because 5 is odd. So that concludes that video on vectors, variables, and associated data manipulations.